Hi everyone, welcome again. In this video, we are going to learn how to use Spring Cloud Open Feign for API to API calls. Open Feign is a third-party project which is used to create declarative REST clients. That means on the client-hand side, we declare what the target service would look like, and the required implementation is generated by the framework at runtime. Spring Cloud Open Feign is a wrapper around the same project, and same as other Spring projects, it simplifies the integration with the help of Spring Boot auto configuration. Let's quickly see what we are going to cover in this video. For instance, we have three microservices: Cart API, Order API, and Notification API. When we submit the order, Cart API needs to call Order API. When the order posting is complete, Order API needs to call Notification API so that it can send the notifications to the user. But as we learned in the service discovery lesson, that it is not as simple as it looks. As we scale up the services, as we add more instances, it becomes complicated because services need to find each other, and when there are n instances running, it's very difficult to locate the required service. And we know to solve that, we added a new component which is the service discovery. So instead of an API calling another API which is not scalable, we will add a new component here which will be the discovery service. So if we revert that, we add a new component in between, which is the service discovery. And in previous lessons, we saw three different ways to implement the service discovery, which is via Eureka, Zookeeper, and Consul. So with the service discovery in the picture, all the services will register themselves with the service discovery, and they will provide some metadata like number of instances, IP, port, health metadata. So here all the services need to register their data with the service discovery, and service discovery has information about all the services. Now when Cart API needs to call Order API, instead of hitting the IP and port directly, Cart API will inform the service discovery that, hey, I need to call the Order API. So it will provide a name that I need to call the Order API. The discovery service has all the information related to the Order API. So depending on the load balancing, it will redirect this request to one of the healthy instances. That's the benefit of service discovery. Now this particular piece where we implement this logic, how to call the target API, we will implement this piece with Open Feign. So in the sender API, we will write the Open Feign client, and via that client, we will call the target service with the help of service discovery. So in this video, we will use Eureka as a service discovery solution, and we will develop three services. The first one will be Eureka server. The second one will be Microservice 1, and we will run at least two instances, instance 1 and instance 2, and the third service will be Microservice 2. Alright, and when everything is up and running, we will call Microservice 1 from Microservice 2. So Microservice 2 will call Microservice 1 via Eureka server. Now as a prerequisite, you need to be comfortable with how service registry works, especially with Eureka server and Eureka client, because that's what we are going to use in this video. If you're not comfortable with Eureka server, Eureka client, then please watch this video, or you can find the links in the description. So let's move on. I'll start by creating a new project. For this video, I'm going to create a multi-module project. You don't need a multi-module project. It's just that I want to keep all the services in one window for the ease of use. So let's create a new project. We'll name it Open Feign demo, and this is going to be a Maven project and Java. That's fine. Let's create. So this is the root project Open Feign demo, and in this project we'll create a new module for the Eureka server. So new module, and this time we'll select Spring Initializer. We'll change the group and the artifact. So we'll name it Eureka server. Eureka server. Let's change the package. Main. Hit next. We need to add the dependencies. So for Eureka server, we need Eureka server dependency. And then hit next and create the project. So this will create a new module under the same project, Eureka server. And if we expand this Eureka server, this is a simple Spring Boot application. It's just that it is acting as a module of the parent project. So if you open the pom.xml, it has its own pom.xml, which has the starter Netflix Eureka dependencies. So let's go to the application.yaml file or the properties file. We'll name it to application.yaml. And in this YAML file, we need to provide some configurations for this Eureka server. So I'm going to copy all the configurations from the previous project. You can find the link of the GitHub repository in the description. This is my Eureka server and we need to copy this. So let's copy all the properties and we'll paste the properties here. So let's quickly understand the properties. First of all, we are defining the port 8090, which means the Eureka server will run on this port on the local machine. Then we are defining the host name, which is localhost here under the client. We are disabling the client mode, which means the Eureka server will not register itself in the reflexive manner. It will act as a Eureka server, and this is the default zone. All right. In the main file, we need to add the annotation enable Eureka server. And when we start this application, this will make this application to run as a Eureka server. That's it. So let's run this application. This will start a Eureka server on port 8090. And we can see that this service is up and running now. So if you go to the browser here, and if we open 8090, this is the Eureka homepage, Eureka server, which is running on the local machine. And as we can see, there are no instances registered with this service because we have not created any other microservice. All right. So we'll go to the same project and this time we'll create a new module. We'll go to the Spring Initializer and this time we'll create the microservice one. So we will name it microservice 1. And it's going to be a REST API, so we need to add the dependencies for Spring Web, and it will be a Eureka client. So this time, instead of this server, we need to add Eureka Discovery Client dependency. Hit next and create the project. This will create another module under the same parent project Open Feign demo. So here is our microservice 1. If we check the pom.xml, we can see two dependencies, Boot Starter Web and Cloud Starter Netflix Eureka client. All right, let's do the same with the application.properties. I'm going to rename it to application.yaml. And then we need to define some properties for this Eureka client. To do that, I'll go back to my previous project, Spring Cloud Netflix Eureka client, and I'm going to copy the same properties and we'll paste the properties here. So first of all, we have defined the port as 0, which means we are not hard coding the port. That means when we start a new instance of this service, Spring Boot will auto assign a random port to that instance. The second thing is we need to provide a name so that the application can register with the discovery service with a valid name, because we have to look up the service by that name. All right. So let's change the name to Microservice 1. All right. And this is the URL where our local Eureka server is running. It's running on 8090 port. So we have defined the same thing here. And then we are providing an instance ID so that each instance has its own unique ID, which is derived from the application name Microservice 1 and the random number or random value appended to this application name. All right. So that means when we run multiple instances of the Microservice 1, each will have its own random port and each will have its own instance ID, unique instance ID, but they will share the same name, which means Microservice 1. Next, we will define a controller that will define the responsibility of this microservice or the job of this microservice. So let's add a simple controller for now. We'll name it Hi Controller. It's going to be a very simple controller because we will be focusing on the Open Feign client, the way one service would call another service. We'll annotate it with REST controller, and then in this controller, we will provide a simple method with get mapping. That means this controller will service HTTP GET calls. And for now, we will return a simple string hi from microservice 1 port. We can inject the port as well, because as I said, we will be running multiple instances, so we need to differentiate which instance serves the request. To get the port information, we can auto-wire environment class, which comes from the Spring framework, and it has these details. We need to auto-wire it. And once auto-wired, we can query the environment class to get the port. To do that, we will say environment.getProperty, and the property name is local.server.port. So whatever port Spring Boot will assign to this service, because remember we have defined the port 0, that means it will be auto assigned when this service starts up. We are fetching that port value here using environment class, and when a client calls this controller, we will see this response, hi from microservice 1 and the port. So when we run multiple instances, each instance would have its own port, and in the response we can identify which instance picked the request. So let's run this service as well. This will start a new instance of microservice 1. So the first instance is up and it has registered itself with the Eureka service discovery. So if we go back to the Eureka server and refresh the page, this time we will see microservice 1, one instance. So there is one instance of microservice 1 running, which is registered with the Eureka server. And if we run another instance of the same microservice, let's say we have to scale up the microservice 1. So we need to run one more instance. All right, we need to copy the config. Let me do that in order to clone this one. So we'll save the configuration, then we'll go to the current file and start a new instance. This will start a new instance of microservice 1. So now we have two instances running of microservice 1 and one instance of Eureka server. And both the instances of microservice 1 have been registered with the Eureka server, and we can verify that. If we refresh the Eureka server page, this time we see the count has been increased to 2 and we have two instances of microservice 1. And if we check out any of these, let's say this one, and we can remove this actuator piece because we are not using actuator and we have not exposed any endpoint. So we can simply rely on the default URL or the root URL. So I can simply remove it and hit enter. And you can see hi from microservice 1, and the port for this microservice 1 is 52852. Which is this one, the second instance. Now let's add microservice 2, which will call this microservice 1 using Feign client. For that, we'll add another module using Spring Initializer. This will be called microservice 2 main next, and the same dependencies, because it's going to be a REST API, and along with it, it will be Eureka client. And this has now created another module under the same project, microservice 2. So all the services, we have bundled them together under the same project. Now, same as microservice 1, we need to provide the same configuration. So we'll go to microservice 2, rename its application.properties file to application.yaml, then open the application.yaml and paste the same configuration. The only difference is this time we will change the name to microservice 2, because for microservice 2 we will run a single instance, so we can hardcode the port. Let's say 8091. All right, so that means microservice 2 will have a single instance and it will use 8091 port, and it will register with the Eureka server with this name, microservice 2. So for now, let's add a simple controller in microservice 2 as well. Greet controller. We'll add the annotation REST controller and a simple method here, greet. And for now, let's return a hard-coded string here, greet, like this. And once done, we'll start the microservice 2 as well. So the microservice 2 is also up and it is running on 8091 port and it has registered itself with Eureka server. Let's check out the Eureka server, refresh the page, and we see another entry for microservice 2, which is the second microservice, and it has a single instance. So we see a single entry with single count. And we can check out the microservice 2. In the same way, we will remove the actuator, hit enter, and we see the output greet, which is being returned from the controller. So we have the setup ready. We have the Eureka service registry running. Then we have two instances of microservice 1 and a single instance of microservice 2. And right now these instances or these microservices are running independently. They are not communicating with each other. And that's what we are going to implement. So let's go to the greet controller of microservice 2. This controller has a single method greet. And let's say instead of returning a hard-coded string, we want to return a custom message. And for that, microservice 2 needs to call microservice 1. And whatever response it gets from the microservice 1, it wants to return the same response with some customization. What we mean by that is whenever a client calls microservice 2, it will invoke its greet method. And instead of returning this hard-coded here, we will call microservice 1. All right. So microservice 2 will call microservice 1. It will get a response from the microservice 1. Then it will use that response to create its own response that will be returned back to the client. So that means if we go to the high controller of the microservice 1, when microservice 2 calls microservice 1, it will return this output. And then in the greet controller, it will customize the same response and return the final response to the client. That means to test this particular flow, we will not call the microservice 1 directly, but we will call microservice 1 via microservice 2. So how do we do that? How do we call microservice 1 from microservice 2 from the greet method? To do that, in order to call microservice 1 from microservice 2, we need to add one more dependency in microservice 2, which is Open Feign. So let's open the pom.xml of microservice 2. And here we will add that missing dependency, third dependency, Cloud Starter Open Feign. So you can find this dependency on the Spring initializer. Refresh the POM. And once we have this dependency, we can start writing Feign client in microservice 2. Because microservice 2 is the caller API, it will call microservice 1. So we need to write the client in microservice 2. To do that, let's add a new package under microservice 2. And we can simply name it model or client, whatever it is. And then we need to add a new file. So in order to write a new Feign client, we create an interface. Let's name it service 1 client. All right, and it has to be an interface. And we need to add one annotation to this interface, which is Feign client. And this Feign client accepts a value, which is the name of the target service. And what is this name? This is the same name that has been registered with the Eureka server. So if we go to the application.yaml of microservice 1, this is the name which has been registered with the Eureka registry. So we need to provide the same name here in the client. So that means when the Feign client will be initialized by the Spring framework, it will look for this service. It will ask the service registry to provide the details of this service because it has to call microservice 1. And for that we use the name. That's why the name is important. All right. The second thing is we need to define the methods in this interface. We don't need to write how to call the API. We simply need to define what the target API looks like. And the simplest possible way is whatever API you are trying to call, just go to the controller and copy the method, not the body, just the method, the abstract part basically, and paste it here at the semicolon. And that's it. It defines the contract for the client. So what we are declaring here is that this is the Feign client, which will call microservice 1, and it will call method hi. It will be an HTTP GET call. And this method call would not accept any parameters, whether it is request parameter or path variable, nothing, because we have not defined anything here. We don't need to provide the implementation of this interface. We are simply declaring the structure of the target API. The implementation will be generated by the Spring Boot and the framework. Okay, so before we use the Feign client, we need to add one more thing So we'll go to the main class of the microservice 2 and we need to add annotation enable Feign clients. That's it. So we have added the annotation enable Feign clients and we have the interface which is Feign client. We have defined the method of the target service. Now let's use this interface to call the method. So we'll go to the greet controller because from the greet method we need to call microservice 1. So we will inject the Feign client in this controller first. To do that, we can auto-var it service 1 client, and same as any other class, we can now call I method on this client. We know it returns a string from the API 1. So let's store it. And now the microservice 2 can customize this response. It can further add, let's say, received response from microservice 2 this. So let's recap what we did. We created an interface, then we annotated this interface as @Feign client, and we provided the name of the target microservice. Then whatever method we want to call, we defined that method as an abstract method, copying the method signature and the annotation in the interface. Next, we added @enable Feign clients to the main class. And in the greet controller, we auto-wired the interface and we are simply calling the method defined in this interface. Notice we are not providing the implementation because the implementation of this interface will be provided by the framework. So we have everything ready. Let's restart microservice 2 and test this setup. So this is microservice 2 and we'll restart the application. Only the microservice 2 because that's where we made this change. So the microservice 2 is up now. Let's go to the Eureka and test this setup. Refresh the page and this time we will call microservice 2. And this time when we call microservice 2, it will call microservice 1 from its controller. It will get some response from microservice 1. And then it will add some additional details to the same response which we should see on the browser. So let's do that. So we got the correct response and notice this is coming from microservice 1. Hi from microservice 1 and port. And this piece was added by microservice 2. That means microservice 2 successfully sent the request to microservice 1 and received the response via Open Feign client. And notice the port number 52852. So let's check the instance of this port 52852. Now this instance of microservice 1 is running on 52852. And if we refresh the page, it means if we send another request, notice the port changed, which is 52836. And this port belongs to this instance of microservice 1. So what's happening here? As we are sending more requests to microservice 2, we see the port keeps changing. Let's send another request 52852, another one, and 52836. The reason behind this port getting changed is the load balancing. The load balancing is automatically handled by the Open Feign client. That means because the target service is running with two instances, two different ports, and so when microservice 2 is calling microservice 1 with the help of Open Feign and Eureka service registry, instead of sending all the requests to a single instance that will eventually overload the instance, it is redirecting the requests to both the instances in the round-robin fashion. So Open Feign is a declarative as well as a load-balanced REST client. So we have seen a simple use case. Let's say we have to pass parameters as well. So let's go to microservice 1. And here in the hi controller, let's add one more method, hi by name. And this time we will add a custom URL pattern as well. Name slash username, which is the path variable basically. And instead of returning this response, we will return a similar response. We will add the past username in the response here. All right. So we added another method in the high controller of microservice one, and this time it has a URL pattern /name and a path variable. So how do we call this method from microservice 2 via Open Feign? To do that, again, we'll copy the method signature along with any annotations, not the body, just the method signature. We'll go to the same interface and we'll add the method signature here for the second method as well. So notice we are using get mapping. We picked the URL pattern as it is. We are also picking the path variable, basically the whole method signature. And after that, we'll go to the greet controller, and instead of calling hi, we can call hi by name, and then we can pass the parameter, let's say dummy. And so this time when we call the microservice 2, it will actually pass a parameter to hi by name, and this call will be sent to hi controller of the microservice 1, and it should be able to translate and capture the path variable. So we should see the updated message on the browser. Let's try this as well. To do that, we'll have to restart all the instances. So we'll start with microservice 2, rerun microservice 2. So microservice 2 is up, and we'll restart both the instances of microservice 1 as well. So this is instance number 1 and instance number 2. So instance 1 is up, instance 2 is also up. We don't need to restart Eureka server. This time let's go back to the Eureka server, refresh the page. We have the updated instances, and in the same way we will call microservice 2. We'll remove the actuator endpoint, hit enter, and this time we see the updated response from microservice 1. It means we successfully passed the parameter to microservice 1. Alright, and notice the ports as we send more requests to microservice 2, these are being load balanced. So we learned how to establish API to API communication using service registry. We learned how to use Open Feign client to call an API from another API. Although in this demo we focused on get mapping, but in the same way we can implement post mapping or HTTP post methods as well. As long as the method is implemented in the target service, we can pick the method signature and paste it in the Open Feign client interface, and then we can use that method as any other method. So that's all for now. See you in the next video. Thanks for watching.